Hello guys. Uh, this is I'm going to start RNN. RNN. Recurrent neural network. That means again and again. Okay. Recurrent neural network are a powerful subset of machine learning algorithm. Okay. That allow for the processing of sequence data by introducing feedback loop into the network. Okay, you have to some points keep in mind in this definition. Mean first of all, you need to be understand meaning here. Recurrent, I am going to explain word by word so that you can get good understanding of this. Recurrent neural network are a powerful subset of machine learning algorithm that allow for the processing of sequence data. We have to learn for sequence data we use recurrent neural network. Okay, for which type of data we use? This we use for sequence data. First thing, by introducing feedback loop, we introduce in this feedback loop two words you have to keep in mind. First is sequence data. Second is feedback loop we use in this network. Okay, network architecture. Whenever interviewer asks what do you mean by R and then you have to tell in simple word two word. Sir, the this is the in, algorithm of that one of the algorithm of the deep learning which are which are mainly used for sequence data and we use in this feedback loop. Okay. Second, vanishing gradient. What do you mean by vanishing gradient? It might ask an interviewer, what do you mean by vanishing gradient? You have to tell when the gradient becomes too small, the network may become unable to learn. Means here you have to understand meaning definition, no doubt you have to explain definition plus and definition you have to tell the meaning of each and every word to your interviewer because you have to understand he is a dumb, he doesn't know anything. You have to make understood them using your skills knowledge. Okay. Yeah, vanishing gradient. What? Which gradient? Vanishing. Which gradient? Once again, vanishing. When the gradient becomes too small, you have to underline too small. Okay? Which word you have to underline? Too small. These things become too small. Gradient. When the gradient becomes too small, the network may become unable to learn. Means when when gradient becomes too small, network does not learn further anymore. That means okay, exploding gradient. That, that means when the gradient becomes too large in this opposite of vanishing opposite of vanishing gradient here is there when the gradient becomes too large. You have to underline this word too large. The network may become unstable and fail to fail, fail to converge. When the gradient becomes too large, to model does not converge. You have to keep in mind when gradient becomes too large, model does not converge. And when model is too small, it does not learn. In case of gradient is too small, it is does not it does not learn. When 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 gradient descent is too large, it does not it does not converge. You have to remember. Okay, this and second solution is given. These are the problem is there. So what is the solution? The solution is there. Techniques such as weight initialization, gradient clipping, and careful network architecture design can mitigate these issues. This is the issues we usually encounter with RNN model. To counter these issues, we use this technique. One is gradient clipping. Second is the careful design of neural network. Means and network. Okay. Application of RNN language modeling, predicting the likelihood of the text word in a sequence. Okay. Second, machine translation, translating that translating the text from language to another. Okay. Then named entity recognition means identifying entities such as people, places, and organization in the text. Then sentiment analysis. That means describing the sentiment in a given piece of text. Okay. Challenges and limitations. Capturing long-term dependencies. Challenging and the limitation. What are the challenges and limitations are associated with this network? First, capturing long-term dependencies. That means vanishing gradient can make it difficult for RNN to capture long-term dependency due to the vanishing gradient. Means vanishing gradient means when gradient value become too large or small. What? Vanishing gradient means too small. Vanishing gradient value too small. Vanishing gradient means when value becomes too small can make it difficult for RNN to capture long-term dependencies. Second, then training and large data set. Training on large data set. This is the one of the challenge. RNN requires large amount of data to train efficiently, which can be drive, which can be time consuming and resource in, and resource intensive. Okay, first you have to understand meaning of training on large training on large data set. What does it mean? Training on large data set. That means all and require large amount of data to train, because this is the topic of deep learning. That is why the deep learning algorithm requires huge amount of data to make a high quality prediction. That is why given RNN require large amount of data to train efficiently, which which can be time consuming and resource intensive. Okay, you have to learn these points today. Someone asked what are and so you have to keep these points in mind. Whenever interviewer explain RNN, you have to explain recurrent, recurrent, recurrent or recurrent means recurrent. Neural network are a powerful subset of machine learning algorithm that allow for the processing of sequence data. Which data? Processing of sequence data. Which data? Sequence of processing data. By introducing feedback loop. By introducing feedback loop. By introducing feedback loop into the network architecture. Okay. Second term you have to remember vanishing, vanishing gradient. Which gradient? Vanishing gradient. That means when the gradient becomes too small, the network may become unable to learn. Okay, then exploding gradient. That means when gradient becomes too large, X, you can remember analogy. Exploding gradient means X means expensive, means extensive, extend means large. So like this, you way you can remember whenever we talk about exploding gradient. That means when the gradient becomes too large, the network may become unstable. That means shade to converge. Okay. Solution. What is the solution is there? These are the problem. So how do we overcome and conquer these challenges? So for this, we use gradient clipping and careful design of recurrent neural network to mitigate these issues. There is written techniques such as weight initialization, what initialization weight, then gradient clipping, and then careful network architecture design mitigate these issues. Okay, the applications of RNN language modeling, predicting the likely output of the text used in a sequence. Machine translation means to translate in Hindi to English, English to Hindi like this. And then named entity recognition, that means identifying entities such as name, people, and organization in the text. And then sentiment analysis, positive, negative, and neutral. To challenge and limitations of these are and are there, capturing long-term dependencies. Vanishing gradient. We have to highlight this word. Vanishing gradient means when gradient become too small. That means it is become too small. Model doesn't learn any further. So for this, vanishing gradient can make different to RNN to capture long-term dependencies. Vanishing gradient can make it difficult to RNN to capture long-term dependencies. Okay. And training on large data set. Uh, This is the deep learning algorithm. It requires huge amount of data. For this is challenge is there. RNN require large amount of data to train efficiently, which can be time consuming and resource intensive. Okay, thank you for today lecture, and tomorrow lecture I will continue from here. And if you have any doubt, please do write in the comment box. Thank you.